to rasterized data that you can then transform into things like slope or aspect, because I know a lot of you are wanting to use contours to help you figure out which locations are most suitable, and so I want to walk you through that. So first, we have our trail, and then we have our huge data set of our contours, the statewide contours. So again, massive data set. If we go into our attribute table, we can see all of our different classes, and we can scroll over to the right and we'll see our elevations. So these are all the elevations that span across the entire state, everything from 0 to 880, etc. So what we want to do is we want to condense this information, because you can bet any processing tool that we use on this data is going to take an extremely long time. So what I suggest you do is go into the model and use the clipping tool and clip the contours with whatever trail buffer you have offset from the North Country Trail, and do that. So I'm not going to walk you through that, but that's what I suggest you do. It's going to cut down on the processing time when you're using the topo to raster, slope aspect, everything like that. So if you don't know how to use the clip tool, go back and watch that video. This will make a lot of sense. It's very straightforward, but anyways, when we run that, we'll go back to our map and we'll see that we now have a 10-mile buffer with the contours, and we're disregarding everything outside of that 10-mile buffer from the North Country Trail. So we're going to go back into our model because that was still vectorized. There was still contours, line segments. So we need to rasterize that. So what we're going to do is we are going to take that clipped output feature class, and we are going to search for our topo to raster tool in our geoprocessing search bar. So again, topo to raster. Again, always using the spatial analyst tool. So you're gonna left click and drag that tool into the model, and we will open this up. So you'll want to connect to the output feature class, which would be your contours, and connect that to the topo to raster tool. So we'll have our feature layer. Your feature layer is going to be contours. Since I didn't label mine when I went through it the first time, output feature class connects there. So output feature class is going to connect here. Our field, we want elevation. That's not the default. The default is object ID. That's not going to help us. So we want our elevation numbers. And then the type is going to be contours. And then your output surface raster is, again, whatever you want to label it so that you can stay organized. So I just labeled mine topo raster, and then everything here can stay as the default. Keep the extents the way they are. Don't mess with them at all. So we're going to right click and run just like we do everything else, and then we're going to get our topo raster spit out for this. So if we go back into our map, you can see that it has successfully run our topo raster. However, now that we've rasterized, we still need to derive this data further, whether we want to look at the slope of the land or whether we want to look at the aspect of the land. So that's what we'll be working on next, but I just want to show you this is the rasterized image. As you can see there, it extends much beyond the 10-mile buffer. That's just how it squares off. That's how the tools run. So don't worry, everything is completely normal. That's how it's supposed to work. Of course, it still clipped out a bunch of other information that we would have had if we wouldn't have clipped previously in the first step. So now we are going to search for our slope tool. Again, the spatial analyst tool. So we're going to click and drag that into our model, and then we're going to want to connect our rasterized topo data to our slope. And then again, this is very straightforward. Your input raster is your topo raster, and your output is, again, whatever you want to label it so you can stay organized. Your output measurement is going to stay in degree, and your method is planar. So these are the defaults. Leave them as the default. Don't change the vertical element at all either. So you can press OK. You're going to right click and run, and then it's going to spit out another output raster. So we will add this to our display. It looks like a beige colored box, but if you look over here on the way that they've outputted the classes, the slope is already extremely steep. So in order to change that, we can go to our symbology, and you can see right now the default method for classifying is manual interval. We want to do a natural break, and then you'll see how the slopes change quite drastically, so it's a little bit more manageable. So you can change however many classes you want. It'll change to however you'd like to classify those. So that's how you output slope from vector data. And then aspect is going to be the same way. However, you're just going to search for the aspect tool. Again, it is the spatial analyst tool. Drag and click that. Go back and reconnect the topo raster to the aspect. And if you guys don't know what aspect is, it's essentially just sun exposure and which way a surface faces the sun, essentially. So you'll go here. Again, your input raster is the topo raster, and your output is, again, organizational tool. Method can stay planar or default. You're going to right click and run. You'll get the output raster, and then we will go to our aspect. And you can see where it's labeling, where it faces north, where the slope faces north. It's going to be red. East is going to be yellow, so on and so forth. So that's how you will graphically display aspect and slope. I hope this helps. I know a lot of you were wondering how to transform vector-based data into a raster. That's how you do it. So let me know if you guys have any questions. Thanks for watching.